Okay, star delta conversions. So you can see here. Here three resistors are there. These three resistors. Their front end and back end. Front end and back ends are interconnected together. So if front and back end of resistors are interconnected together, that is known as delta connection. Okay, and if three resistors are there, okay, only one end of these three resistors is connected to a common terminal, that is known as star connection. Okay, so this common terminal is, you can even call it as a node or a junction, meeting point of all these resistors. So if three resistors are connected, their front end and back ends are connected together, they form a delta connection. If one end of all the three resistors are connected to a common point, they are said to be connected in star form. Now I can convert either delta to star or star to delta converted system. Means if resistors are connected in delta, you can convert them into star. If resistors are connected in star, you can convert them into delta form. Okay, so for that, how to convert directly? There is a derivation, but here in this session, I'm going to discuss directly how to write the formulas instead of going for deriving the expression. So simply what we have to do is, if I have a delta connected resistors, and if I want to convert that delta connection into star connection, I have to put a dot within this delta connected circuit. You can consider it as N node, and you can put dotted lines here from this dot towards the meeting point of these resistors. Okay, okay. So if you see here, besides to this dotted line, I will change the color. Besides to this dotted line, color did not change. Yeah. Besides to this dotted line, what is there? RAB and RAC is there. Okay. So I will put a dotted line, and so there is a dot here. I have erased. Put a dot at the center of the delta connected connection. Draw a dotted line towards the meeting points of these resistors. Okay. So consider this dot as some node N. This is N. I'm unable to write N. This is N. Now you just observe these two resistors. So what is this? RAB. What is this? RAC. So what is common here? A is common. So this dotted line here you can write RA. And now besides to this dotted line, what is this? This is RAC. This is RBC. So what is common between these two resistors? C is common. So I can write RC here. RC. Okay. Similarly, just observe this resistor and this resistor. What is common? RAB and RBC. B is common. So I can write RB here. Okay. So these dotted lines, the resistances. I have given notations to these resistances RA, RB and RC. Now what is RA? What is RA? Besides to RA, you just observe. Besides to RA, what resistors are there? Besides to RA, RAC is there, RAB is there. So RA is equal to RAB into RAC whole divided by RAB plus RAC plus RBC. Okay. Simply, directly from this, instead of going for derivation, instead of deriving the expression for RA, simply directly I can write down the RA expression. So what is RA? Besides to RA, RAB is there and RAC is there. So RA is equal to RAB into RAC whole divided by RAB plus RAC plus RBC. Okay, that's it. It's my RA. What about RB? RB, just see. Besides to RB, what is there? RAB is there, RBC is there. So RB is equal to RAB into RBC whole divided by RAB plus RBC plus RAC. Okay, next, that is our RB. RB equal to RAB into RBC whole divided by RAB plus RBAC plus RBC. What about RC? Besides to RC, what is there? RAC and RBC is there. Okay, besides to RC, RAC and RBC is there. Therefore, what is RC? RAC into RBC whole divided by RAC plus RBC plus RAB. Okay, so directly from this um, delta connected resistors, you can get the values for star connected resistors. Now, if I have star connected resistors and if I want to convert them into delta, so once again what I will do is I will just join these terminals I will join A with C and C I will join it with B and A I will join it with B. Okay, so if I join, I can write the resistance values. So what is resistance between A and C? I wanted red color, I couldn't get it. Notation. What is the notation? R A C. Okay, R A C. Similarly, in between B and C, what is the resistance RBC? Similarly, between A and B, what is the resistance RAB? Okay, simply what you have to do, we have to just join the terminals and depending on the terminal notations, you can write RAC, RBC and RAB. Now if you see here, RAC is there. What is RAC? So instead of this expression, let me see. I have one more expression here. So here you just see here. Okay, so I will explain from instead of these are a bit complicated, I'll tell you even simpler, very simple expressions. Okay, which in another slide it is there, but they are in numerical terms. That's why, okay, I will explain here itself how to write the equations. So here, so R A C. So there is not even necessary for you to look into the diagram, in star connected circuit. If you want to convert star into deltas, this is RAC. So you can write RA plus RC. We can easily write it, isn't it? RA plus RC plus RA into RC. RA into RC. What is left over? What is left over? RB is left over. Divided by RB. Divided by RB. Okay. So here it is. So what is RAC? RAC is equal to what? RAC is equal to RA plus RC plus RA into RC divided by RB. Okay. So next, let me write one more expression, that is R. I will write RBC. RBC. So RBC is equal to RB RB I'm unable to write B here, my cursor isn't to me. So, okay. So RB plus RC. RB plus RC plus RB into RC. RB into RC. RB into RC divided by what is left over? RA. Okay. So instead of writing these expressions, these are also right, but instead of writing those expressions, you can write like this. Okay. So what is left over? What is left over? RAB is left over. So RAB is left over. I will just erase C here and I will write B here. So RAB. RAB. RAB is equal to RA plus RB plus RA RB RA RB whole divided by what is left over? RC. Okay. Okay. So either you can write these expressions or it's I have told you the simplest way to write down the equations to convert star to delta, delta to star. Okay, so you can see here. I will just leave it for a minute so you can see the images and you can just see how equations have been written. Okay, so that was in terms of resistance. Now these expressions are in terms of impedance. Okay, now let us see a numerical problem. So in this numerical problem, if you see, they have simply asked us to determine the equivalent resistance between the terminals A and B. So if see some simply we can go for network reduction method to determine the equivalent resistance. So where is it? Yeah, we can to determine the equivalent resistance. So if we observe here carefully, okay, if you observe here, these three resistors, they seem, these three, not three, these four resistors, they seem they are connected in parallel. Okay, so in between terminal A and B, and if you observe these three resistors, it seems they are connected in parallel. These three resistors are also connected in parallel. It seems they are connected in parallel. So sometimes, you know, so if star delta connected elements are there, if elements are connected in star or delta connection form, so it becomes harder to simplify the circuit. So you must know the star delta conversion, otherwise you won't be able to simplify the given circuits. So sometimes while reducing the given network, we have to go for star delta reduction method. Okay, otherwise you won't be able to simplify the circuit. So here in this given circuit, it is not easy. Without going for star delta conversion, you can't simplify the given circuit. So okay, so now if you carefully where is my cursor, yeah. So here what I am going to do is, this is one terminal, this is one terminal, this is one terminal, and this is one terminal. So for me, these three resistors look as if they are connected in star. Okay, so I want to convert them into delta. So for that, what I am going to do is, I am going to put a dotted line between C and E terminal, and I am going to put a dotted line between this C and B, and from B I am going to put a dotted line up to E. Okay, now what is this resistance? R C E. What is this resistance? R C B. What is this resistance? R B E. Okay, so this is it. Now if I know the conversion formula for star to delta, I can go for conversion. So what is it? See, I have done in the other slide. This is RCE, RBC and RB. So what is RCE? RCE is between, okay, what are the resistance here? In front of it, 2 ohms and 3 ohms is there in front of RCE. In front of RBC, 2 ohms, 4 ohms is there. In front of RBE, 3 ohms and 4 ohms is there. So RCE, okay, so RCE is equal to, what are the resistance that are available in front of it? 2 ohms and 3 ohms. So RCE is equal to 2 plus 3 plus 2 into 3 divided by opposite to it is 4 ohms. Okay, so So RCE is equal to 2 ohms plus 3 ohms plus 2 into 3 divided by opposite resistance. You will get RCE as 6.5 ohms. Similarly, RBC. In front of it 2 ohms is there, 4 ohms is there. So RBC is equal to 2 plus 4 plus 2 into 4 divided by what is left over? 3 ohms divided by 3. So RBC is equal to 2 plus 4 plus 2 into 4 divided by 3. You will get 8.66. Next, RBE. What is the RB in front of it? What is the resistances that are? What are all the resistance? There are 3 ohms and 4 ohms. Okay, 3 ohms and 4 ohms are available. Okay, so RB is equal to 3 plus 4 plus 3 into 4 divided by what is the opposite resistance? Leftover resistance 2 ohms. So divided by 2. Okay, so divided by 2. So what is that is there in the next slide? So REB 3 plus 4 plus 4 into 3 by 2, you will get 30 ohms. Now replace what to say. Now you just remove all these resistors. Instead of them, draw RCE, RBC, and RBE. So you will get this circuit and replace this resistance values with the one you have calculated. Okay. Now these two resistors, see here, they have common beginning terminal and ending terminal. These resistances, this resistor and this resistor also have common beginning and ending terminal. But these three resistors, they are not looking as if they can be simplified by series parallel combination. If you see here, this is one terminal, this is one terminal, and this is one terminal. So these three resistors are between three terminals, means it is delta connection. So what you have to do, you have to put a dot here and draw a dotted line. Draw a dotted line. Draw a dotted line. Okay, so I might have already drawn it. See here, I have considered this as N. So here terminal A is there, so RA. Here terminal C is there, so RC. Here terminal E is there, therefore RE. I have written R1, RA, RC and RE. Okay, RC, RA and RE. So if you remember the formula, you can easily solve it. So you just see here this RA, besides to it, what is there? 4 ohms and 2 ohms is there. So RA is equal to 4 into 2 divided by 4 plus 2 plus 6.5. Okay, that is RA. Similarly, RE, what is RE? Besides to it, what is there? 2 ohms is there and 6.5 ohms is there. So RE is equal to 2 into 6.5 divided by 2 plus 6.5 plus what is left over? 4 ohms. So 4. Okay. Similarly, RC. Besides to it, what is there? 4 ohms and 6.5 is there. So RC is equal to 4 into 6.5 divided by 4 plus 6.5 plus 2 ohms. So that's what I have done here. RA, RC, RE. So after determining that, my circuit has changed somewhat like this. This is it, new circuit. Okay. Now as I have already told you, these two resistors seems to be connected in parallel. These two resistors seem to be connected in parallel. So I can further simplify them. Okay. So I can simply parallel connected. So this simplification 3 into 8.66 divided by 3 plus 8.66. I will get a single resistor. So here 13 into 1 divided by 13 plus 1. Okay, so that I might have done here. See here, R resistance of 3 connected, 3 parallel to 8.66, resistance of 13 parallel to 1. 3 into 8.66 divided 3 plus 8.66. 13 into 1 divided with 13 plus 1. So this I can write it in terms of equation. I don't know why earlier I didn't write it. So here I can write the equation. I will write it now itself so that it will be more easy to understand. So if you simplify 3 into 8.66 by 3 plus 8.66, you will get 2.23 ohms. Next. Uh, so this is it. The parallel connected elements, parallel connected resistance values. I have calculated. I have got 2.23. And the resistance parallel connector I have 0.98. So I have written 2.23 here and 0.9839. So maybe it is 0.13 divided by 14. Let me check the answer. 13 divided by 14. You will get 9 point. Yeah, it is not 8, it is 3. I have written it. It is 0.93. Okay. So now by looking at this diagram, it is clearly understood that these two resistors 2.08 and 2.23 are connected in series. 1.4, 1.04 and 0.93 they are connected in series. So you can simply add these two resistances and add these two resistances. You will get this. So 4.31 and 1.97. Now these two elements they are connected in parallel. These two elements they are connected in parallel. So if we simplify that parallel combination, equivalent resistance is what? 4.31 into 1.97 divided by 4.31 plus 1.97. Okay, see this these terms which whatever I have got that I have solved it. I have written it here. Here I have written it. 1.97 value and 4.31. Now parallel combination it is simplified. I will write the equation here. So for simplifying the parallel combination, this is the resistance that I have got. So what did I get? 1.35. So this is my 1.35. This is 1.35. This 1.35 and 0.64 they are connected in series. They are in the same line. So you just add it. 1 point something you will get. Will I get 1 point or 2 point? Let me check. Okay, so you will get some 1.99. Okay, so simply add it, you will get 1.99. So this is my last term, equivalent resistance for the given circuit. So see here, simply by series parallel combination technique, so network reduction technique, you can't simplify this given circuit. Uh, you have to go for star delta conversion method, otherwise you can't simplify it. Okay, that's it.